Hi, this is Alexandros with alexandros.io, and in this video we'll be going over TwoSum, a coding interview problem that has appeared in interviews for companies such as Amazon, Adobe, and Google. First, let's take a look at the problem definition. The problem asks, given an array of integers and an integer target, return the indices of two numbers whose sum equals target. Furthermore, we may not use the same element twice, and we can assume that each input has exactly one solution. For example, given this array and a target of 9, we must return indices 0 and 1, since the elements at those indices, 2 and 7, have a sum of 9. Our initial brute force approach could be as follows. Loop through the array, and for each element x, check if the array contains a value y, where target minus x equals y. In other words, for each element of the array, check if the rest of the array contains a value which when added to it gives us a sum equal to target. Using this array as an example, and the target being 10, we'll start by taking 7 and look through the rest of the array to see if it contains the value 3. As you can see, our array does not contain 3, so we can move on to the next element. We will now take 2 and look for an 8 in the rest of the array. Success! Our array contains an 8 at index 3. As a result, we can return 1 and 3, and we are done. At this point, we can examine the time and space complexity of our solution. The time complexity of this solution would be O of n squared. This is because for each element in the array, we look for its complement by looping through the rest of the array, something which takes O of n time. The space complexity will be O of 1, or constant, as we don't use any additional data structures whose space requirement depends on the length of the array. The space complexity of our initial approach is great, but the time complexity not so much. We can do better by using a dictionary or hash table and trade off some space for time. In this approach, we loop through the array, and for each element x, we check the hash table to see if we have already encountered the value y, such that target minus x equals y. In other words, for each element of the array, perform a hash table lookup to see if we have previously encountered a value which, when added to our current element, gives us a sum equal to target. If we have, we can return the indices of x and y. Otherwise, we will add x in the hash table as a key and its array index as a value. Let's work through an example to make things more clear. When given this array and a target value of 10, we'll start by taking 7 and perform a hash table lookup for the value 3, since our target, 10 minus 7, equals 3. Our hash table does not contain 3, and so we'll add the 7 and 0 key value pair in our hash table. In the next step, we'll take 2 and perform a lookup for the value 8. Once again, our table does not contain an entry with 2 as the key, and so we'll add the 2 and 1 pair to the table. In the next step, we'll take 1 and look for a 9 in our table. Our table, yet again, does not contain the value we are looking for, and so we'll add the 1, 2 pair to our table. Finally, we'll take 8 and perform lookup for its complement 2. Awesome! Our hash table contains a key equal to 2, and so we can return 1 and 3, the index at which we encountered the value 2, and our current index value, respectively. Using this approach, we have a time complexity of O of n, because we traverse the array just once, and for each element we perform a single hash table lookup, which is an O of 1 operation. Our space complexity will also be O of n, and that is because we use the hash table, which may contain up to n entries. Now, let's take a look at this Python solution, which uses the hash table approach. We start by initializing a dictionary, which will hold the values we have encountered so far, and their position in the array as key value pairs. Then, we use enumerate to loop through the array. I use the enumerate here because it keeps track of both the index and the current element, eliminating the need for an additional statement to access the element at every index. In the next step, we subtract the value of the current element from target to calculate the value we need to look up in our dictionary. In the next step, we perform the lookup, and if the complement exists in the dictionary, we return the current index and the index at which we encounter the complement. If not, we'll add a new entry in the dictionary with the current element as key and its index in the array as the value. And since we know that we are guaranteed a solution for each input, there's no need to return something outside the loop. And that is it. Try coding up the solution to this problem yourself, and best of luck with your lead coding. If you have any feedback, please comment down below, and if you would like to see more, like this video and subscribe to my channel. This has been Twosome with Alexandros for alexandros.io.